Today we are going to look at sketching graphs using a linear equation. We've looked at what a linear equation, what parts it has. So it's y equals mx plus c. Our m is our gradient, our c is our y-intercept. We know these parts, but sometimes we really struggle to understand when we just see this equation, it actually means it's drawing us a line. So if I gave you the linear equation y equals 2x minus 1, if it was just written on the page, we can't really understand or think about or picture what the line looks like. So we're going to show you using just the linear equation how we can get a straight line on our Cartesian plane. It's not as hard as you think. All right, first thing we need to do is pick some x and y values. So here's my x values, here's my y values. And we know that the y values depend on what our x are, or our x values are. So if we go nice and easy, we go 1, 2, or 0, 1, 2, 3 for today. They relate to 1, 2, and 3, and 0 on the x-axis. So we understand that. Now, when x is 0, we have to calculate what y is. So let's go over here. When x, let me help you. There we go. When x equals 0, y is always going to equal 2x minus 1. This time we know the x value is 0. So y equals 2 times 0 minus 1. 2 times 0 we know is 0. We've still got our minus 1. 0 minus 1 is negative 1. So we can over here take that value and go, all right, when x equals 0, y equals minus 1. We can do that with all our other points. Let's do that over here with when x equals 1. This time we're doing this point. When x equals 1, y is always going to equal 2x minus 1 because that's the equation we are working with. So this time, x value is 1. So 2 times 1 minus 1. 2 times 1 is 2 minus 1. 2 minus 1 is 1. So our y value that sits in here is 1. Let's do that again. When x equals 2. Y is going to equal, same thing, 2x minus 1, which equals this time 2 times 2 minus 1. 2 times 2 is 4 minus 1. 4 minus 1 is 3. So our value for when x is 2, y is 3. Last one, when x equals 3. Y is still 2x minus 1. That's the rule every time. So that is 2 times 3 minus 1. 2 times 3 is 6. We're still taking away 1. 6 times 1 is 5. So our value is 5. Now none of this is meaning anything until we put it on our graph. So if we move back up and have a look at our graph, here are our points as well. So you've got to be able to see both. I'll just fix that. Sorry. There we go. We can see what we need to see. Ooh, no we can't. Sorry guys. It's fiddly today. Okay. So we've got our Cartesian plane up here and we are going to graph these values. So we've got when x equals 0, y is negative 1. So across 0 and down 1. Across 0 we stay here and we go down 1. Here is our first point. We now go across 1 and we go up 1 this time because it is a positive. So across 1 and up 1. Here we go. We can see our line is starting to form. Our next one is across 2 and up 3. So we go across 2 and up 3. There is my point. I now have to go across 3 and up 5. So across 1, 2, 3 and up 1, 2, 3, 4, 5. Okay. Now my graph is very rough my graph isn't the most accurate thing, but even that, I can see a line is starting to form. So if I was doing it accurately on graph paper, I would have a nice straight line. So if I ask you to sketch a graph using just the rule, the best thing to do is choose some of these types of coordinates. So when x is 0, 1, 2, 3, then we can calculate the y value.